All right, you are welcome back to linear programming. We still continue with our introductory mathematical analysis A, and we are still in chapter 7 of linear programming. Now we started linear programming where we have the formulation like this: maximize z equals to 4x plus 2y. I'm just taking an example, not exactly like the one we did before. Subject to 2x minus less or equals to 5 x plus y less or equals to 10, s greater or equals to 0, y equals to 0. So this is the linear programming formulation. This formulation, sometimes you are given this formulation, you are asked to find the solution. Okay, that is fine. That is easy to do, so to say. Okay, but the meat of linear programming is you finding this formulation yourself, formulating this linear programming yourself from the word problem. So you are going to be given a word problem, and you are going to be asked to formulate this linear programming formulation or model yourself. Okay. Now, in order to do so, when you are given a word problem, you must find the mathematical expression of those word problem. That is what we call linear programming formulation. Okay, in order to do so, you need to, step number one, you need to draw a graph from the information given in the problem. So don't forget, you are going to be given a word problem, and then you have to draw a table. It's always good to draw a table from the information and determine the system of constraints and objective function. So from the word problem, you are going to determine your objective function, and then you are going to be determining these ones. These ones are because the real world problem you are dealing with is non-negative. It's not negative. So you are going to be adding this to all your formulations. Okay. All right. So with applications, we usually have additional constraint, which is this one, as I've mentioned before. They are non-linear constraint, non-negative constraint. Sometimes we have our variables to be integer only, but this time around we are just considering these ones for now, okay, for your level. Okay, step 2, you must draw the visible region. As we have done before, you use the constraints to draw the visible region. Then step 3, determine the coordinate of all the corner points. You must determine the coordinate of all the corner points of the visible region. We did that before. So we need the corner point. And sometimes you need to solve for the intersection of two lines to get a corner point. Sometimes you need to solve for the intersection of two lines to get a corner point. Okay, just like we did before. So if you have not watched the previous video, please make sure you do so. Then from that corner point, we need to know which one is maximum. Is your asked to maximize, or minimum if you are asked to minimize. You need to determine that. Okay, so you put each of the corner point into your objective function to know which one gives you the maximum or which one gives you the minimum, depending on the problem you are dealing with. Okay, I hope you understand that. Okay, now this is an example of a word problem that will be given to you. It's an example of a word problem. So whenever you are given a word problem like this, please read it again. Read it the first time. If you cannot pick out some things, read it the second time. In fact, you might need to read it the third time or fourth time so that you can understand properly. Is that okay? So let's go. We need to buy some filling cabinet. You know that cabinet S costs this per unit, $10 per unit. Requires 6 square feet of floor space, holds 8 cubic feet of ice. Cabinet Y costs $20 per unit, requires 8 square feet of floor space, and holds 12 cubic feet of ice. You have been given $140 for each for this purchase. Though you don't have to spend that much, the office has room for no more than 72 square feet of cabinets. How many of which model should you buy in order to maximize storage volume? Okay, this is what we are doing. So now you have to determine, are we maximizing or minimizing? From here now you can pick up that we are maximizing. Please, it's very important for you to know, what are you doing? Are you maximizing or minimizing? So here we can pick we are maximizing. Okay, let's look at what is given. We have two cabinets, we have X, we have Y. Okay, so don't forget to draw a table. Always learn to draw a table for it. So, and always write your variables. Let X be the cabinet X. Okay, that is obvious, but sometimes they will not give you cabinet X and Y. You are the one to determine which one should be X, which one to be Y. Okay, but this one, cabinet X follow to be X, and cabinet Y will follow to be Y. Okay, let Y be the cabinet, okay, Y. Okay, or we can say it properly, let X be the number of model in cabinet X. Okay, because we are looking for which model should we buy. Let X be the number of model, okay, in cabinet X, and let Y be the number of model in cabinet Y. Okay, that is fine. So let's write that here. We have X, we have Y. Okay, that is fine. Okay, now for X, look here, for X we have what? For S cost this. There's a cost attached to X. There's a square feet attached to X. And there is a cubic feet. This cubic feet is the volume. Okay, so let's write that. There is a cost. There is a floor space. Yeah. And then there is a volume. That volume is for cubic. That one is for cubic feet we have there. Okay, you see. So for X we have 20, we have 8 here, and then we have 12 here. No, for Y. For X we have 10, we have 6, and we have 8. 10, 6, 8. 10, 6, 8. Okay, this one is 20. What else is that one? 20 for cost of Y. And then for floor space, we have 8, and then we have 12. We have 8, we have 12, we have 8, we have 12. Okay, please read the question again and make sure you understand. Now, in linear programming problem, you will be given like 2 things or 3 things that has different values of those things. Like for example, for cabinet X, we have cost, we have floor space, we have cubic feet, which is the volume, and the associated number. The same thing for Y. Okay, that's why we're able to pick out this from there. But let's finish reading. You have been given $140 for this purchase. So there's 140 limitation or restraint on the cost. Did you see that? On the cost. Though you don't have to spend this much. So you can spend up to 140, but you cannot spend more than 140. Okay, because you cannot spend more than 140, that shows the cost can only be spent less or equals to 140. Please take note of this. So we now use the sign less or equal to, not greater than, or not greater than or equal to, no, less or equal to, because you can only spend less than or up to 140. So this has a restraint, this has a constraint on it. Okay, this I will use a restraint because the whole of this will now make our constraint. Okay, but this has a limitation. Okay, I can also use limitation so that you can understand what I'm saying better. This has a limitation. The cost has a limitation. Let's go on and see which one also has a limitation. The office has room for no more than 72 square feet of cabinet. So the floor space also has a limitation, which is 72, no more than. So we cannot spend more than that also. So the floor space has a limitation. Let me use another color. The cost has a limitation. The floor space also has a limitation. Can you see? Because you cannot use more than 72. So that's why we are using less than or equal to, because you cannot use more than that. So the cost has a limitation. The floor space also has a limitation. Let's see, maybe this volume has a limitation. Okay, how many of which? So there's no limitation for volume. So anyone you don't have limitation on, that will be automatically our objective function. That will be our objective function. Please take note of that. You will have limitation for everything except for the objective function. You have limitation for everything except for the objective function. So this automatically is our objective function. So if we are to formulate the constraint now, okay, or the linear programming problem now, let's formulate the linear programming. So our linear programming formulation, will now be, don't forget, because this does not have a limitation, that is our objective function. So we are going to have, what are we doing? Are we maximize or minimize? We are maximizing. Maximize z equals to, this will be 8x and then 12y. Okay, so we have the 8x plus 12y. Okay, that's our objective function, maximizing that. Okay, now subject to, we now want to write the constraint. Subject to, don't forget, we only write the constraint for those items that has limitation. Okay, so we have 10x, 20y, then this is the limitation for that. Okay, so we have 10x plus 20y less or equals to 140. And then for this one, 6x, 8y less or equals to 72. 6x plus 8y less or equals to 72. Okay, this is our linear programming formulation. But don't forget, in our linear programming formulation, we must add the non-negativity constraints. That means x must be greater or equal to 0. And then we can also have y greater or equal to 0. Okay, this is our linear programming formulation. So we have the objective function, which we are maximizing, and then we have the constraint with the non-negative constraint. Okay, that is our linear programming formulation. So You see now we formulated this one from our word problem. We formulated this from, unlike the other one that they gave us this, and we are asked to solve this. Now we formulated this, then we now solve it. Just like we did the other one, we need to solve it by drawing the graph for it. So if you draw the graph, your graph should look like this, and then your visible region is this one, with our corner point of this, corner point this, corner point this, corner point this. This is 0, 0 is trivial. We are not always looking for 0, 0, okay, but it's part of the corner point. So all these ones are our visible region, So we have a point A here, which is A3, which is the intersection of these two lines. We have point C there, we have point B here. So we are going to put each of these points into our objective function. Don't forget our objective function is this one. Okay, we are going to put each of them into our objective function and see which one gives the maximum. Again, our objective function is this. We are maximizing. So putting each of the points into our objective function, we get that this is the value that gives us the maximum. So the maximum is this point where x is 8 and y is 3. That is our maximum. Don't forget, we need to test the corner point, each of the corner point, and check which one gives the maximum. So if we are minimizing, you check for which one gives the minimum. But if you are maximizing, you check for which one will give you the maximum. Which one will give you the maximum. All right, please make sure that you understand that. Make sure that you understand that. Thank you.